Let's learn more about the basic components of our data center. So let's first take a look. Returning to the question, what is a data center? The definition in Wikipedia is the data center is a complex set of facilities. It includes not only computer systems but also others. Some devices that go with it. For example, communication, storage systems, and so on. So here it emphasizes computation and storage. And communication can be understood as a network. Also includes redundant data, communication connections, and environmental control, monitoring equipment, and various security devices. So this is the definition from Wikipedia. From this we can know it has a computing server, there are communication networks and storage devices. And there will also be some environmental control and monitoring. So what might be emphasized more here? The emphasis is on capable machines, network energy, UPS, power supply, and so on. Air conditioning, monitoring these things. So this is Wikipedia. So what is Google's definition? The data center is a multifunctional building, can accommodate multiple servers and communication devices. These devices are placed together. It's because they have the same requirements for the environment, as well as the need for physical security. And this placement facilitates maintenance. And it's not just a collection of some servers. We know that now these are our servers. It is put together. It is because it has the same environmental requirements and it's easy to maintain, right? So about our data center, it is usually a large-scale data center and it will include a lot of these physical servers, network devices, and so on and so forth. So from Huawei's perspective, how does Huawei define a data center? When we talk about data centers, it's similar to a reservoir. The data center solution is similar to a lake. We can take a look. We know our data center. In here, we will have a lot of physical servers and some storage devices and the network of the data center. So its actual value exists. It is to provide some corresponding services to the outside. For instance, we start from seen in the table in the bottom right corner. For example, the network pipeline of the operator. Enterprise's network pipeline, network terminal data flow. It is through some channels provided by the data center to the outside, to provide some services to the outside in this form. Therefore, the value of our data center has emerged as a result. So this is the data center. So let's take a look at what comes next. The modular composition of this data center. In this picture, we have two. The diagram on the left is called the full view of the L1 layer of the data center. It is a picture of the infrastructure. The second one is the L2 layer of the data center. The full view of ICT equipment. So this is some L2 layer equipment. Then I can also introduce it to everyone from my side. We are discussing this data center. Actually, we can divide it into L0 to L4. These four levels. We are discussing this L0. Actually, this L0 in the data center is for building construction. Simply put, it is to build this data center house, which refers to civil construction. So with this L0 layer that is after this house exists, we will go to this L1 layer as the second step. This L1 layer often covers things similar to those in our picture power distribution facilities, cabinet plus wiring system management and operations center and cooling facilities, etc. So this is some basic infrastructure layer. So this is the L1 layer. So the L2 layer refers to these IT infrastructure layers on our right. This level includes the server storage network and some virtualization software and some cloud computing software. This is the L2 layer. So what is the L3 layer? Layer 3 is often the platform for some applications. Layer 3 is a platform for some applications. While the L4 layer is business oriented, for the keyword, this level is various services you can. Understand this as the L4 layer. It's all kinds of services. So this is our data center. The distinction from L0 layer to L4 layer. So our HCNA is also good. HCNP is also good. HCIE is also good. The establishment of the certification system for our course. Our main purpose is to draw everyone's attention to what matters. The focus is on some corresponding services from L2 layer to L4 layer. So regarding the L1 layer and the L0 layer. First of all, we won't let everyone build houses. So our L0 layer is not something everyone needs to know. So the L1 layer requires everyone to have a basic understanding. What exactly do we have in this infrastructure? What is probably needed? This is what we need to know. So these are our only requirements so everyone can understand it simply. The key is to understand L2 to L4. The key point is layer 2. So the development history of this data center. Why did I put another page here? It's because what we are discussing here is the history of infrastructure development. What we just discussed is the overall development history of the data center. We just briefly discussed the birth of our first electronic computer, right? So in 1956, China also developed the first electronic computer. So IBM entered China in 1979. So China has also introduced advanced computer equipment, and the concept of informatization entered China in the early 1980s. At that time, this data center was actually not called a data center, called the machine room. There are also no corresponding construction standards and bases. It is implemented solely based on the requirements of the product installation manual. The first electronic computer successfully developed in China. It was successfully developed by Harbin Institute of Technology. So this is the history of data center computing. Then why do we talk about the history of computers? It's because the development history of our data center is actually very short. Why is it short? It's because our data center must have had this computer. Afterwards, only then will this data center exist, right or not? Therefore, the history of the data center is also the history of the development of electronic computers. So, by the early 1980s in our country, we have just started to establish some corresponding standards and norms for data center construction. Some national standards, for example, GB 288782. It is our first national standard in 1982. It will have some corresponding requirements for data center construction. So this is the development history of our data center. So basically, in the 90s, the internet entered China. In fact, it was then that the real modern sense of the data center began. So entering the 21st century with the development of China's economy and the popularization of information technology, the daily life and production of Chinese people. All are closely related to the information system, IT systems, and informatization construction. They have all become the driving force for enterprise development. So, about our data center, infrastructure also serves as a support for the IT system. So we can see from this diagram, we can combine this diagram, the first picture in the bottom left corner and the second picture. This is from 2008 to 2010, the world and China's. The sales scale of the technical facilities market in this data center, we can take a look. In terms of the world, it is showing a gradual growth trend. Although in 2009, you can see it was only 1.8, right? Because there was an economic crisis at that time, it is still growing. So we can see the demand for this technical facility is very large. So let's take a look at it in China. Corresponding to it in China, we can see our development speed is faster than the world's. Because the speed of economic development in our China is very fast. You can also see that 2009 was relatively less. It's also because of the economic crisis, but it is all presented gradually increasing trend. Of course, this is also related to the construction of data centers in China, relatively late to start. So our growth rate will also be higher than the next two tables. It is a prediction for the future data center. So actually, this is relatively speaking a bit of an achievement. It's from 2010 to 2016. You can also see that its trend is also. The development speed will gradually increase. The market prospects are also very good. So this is the process of our infrastructure development. Let's take a look at the development trend. Development trend of data center infrastructure. Previously, we discussed IT systems and information construction has become the driving force of enterprise development. That is to say, to be precise, the development of a company should be the development of its business. It constantly proposes to IT systems and informatization construction requirements. This is also our data center construction and development prime mover. So, conversely, development of the data center. The implementation of various functional services also promotes the enterprise's further development. The development of data centers has raised requirements for relevant information technology. New requirements. Conversely, the emergence of new technologies and materials also makes it possible. New requirements for the data center satisfies the development of the data center. At the same time, it promoted the progress of the enterprise. For instance, expansion of a certain enterprise's business, it aims to enable the daily scale of the data center. The overall scale will continue to grow. Then the daily operation and maintenance management will become increasingly complicated. So the cost will also be higher. The risk will also be greater, so to speak. Intelligent management of the data center. At this point, wouldn't it be brought up in the schedule? We need to consider intelligent management. So, what are the requirements for intelligent management of data centers? It requires automated data collection. So we have proposed a requirement for automated data collection. Corresponding to it is the respective database. Proposing requirements for application handlers and front-end display platform technologies. So you can see with the maturation of new materials and technologies. Implementation of intelligent management in data centers, while improving the data center itself, eliminated the bottleneck of enterprise development, promoted the further improvement of enterprise business. So looking at this example, the development of the company's business is also good. The development of data centers and the advancement of new technologies are good. They are actually the three. It is a complementary process. It's also a mutual restriction. They also promote each other. At the same time, the development of corporate business is the driving force of data center development. That is, development determined by demand. So, what changes have occurred in our data center over the years? Let's get to know. Firstly, the first one. In terms of the data center, there are a few changes. It is developing from a single service to multifunctional services. The functionality of previous data centers was definitely relatively simple. In the past, it was mainly centered around the data center, mainly provide support for the production of enterprises. The functions of the data center may have changed. Now the service features will increase. Not only supports the production of enterprises, also for the management, training and daily activities of the enterprise. All need to provide support. So this could be from a single service, development of multifunctional services. So the second one is scale. The scale of our data center also undergoes significant changes. The scale is getting bigger and bigger now. Although the density of our IT system is getting higher and higher, the degree of refinement will continue to increase, but still can't keep up with our society's expectations of an enterprises. With the growing demand for information systems, so the scale of our data center is gradually getting larger. Also, the status of the data center. In the past, some enterprises it does not have its own corresponding data centers. Perhaps considering safety is also good for now, considering the reliability of the data is also good. It may have some self-built data centers, we call it a private cloud. So, the status of this kind of data center in enterprises is gradually becoming higher and higher because its demand will be higher. So, the fourth is the change in the consumption model of the data center. It has transformed from a pure consumption type to an investment profit type. Let's not talk about the external operations of IDC and the like. For now, that is, services similar to, for example, public cloud. Discuss the operation of the data center within the enterprise. For example, more and more businesses are emerging now. Consider the data center as a resource. It could be said that there are 4 data centers within my company. So, from the perspective of the enterprise's internal operations, every department actually needs to use these resources, but every department has to compete with each other. Because I might say that every department has needs. Who should I listen to after all? We will then carry out some corresponding control over this area. So, in terms of data centers, improve the service content and quality of the data center. It has also become a promoter of the management and development of data centers. So this is the development trend of our data center infrastructure. Let's look at the future. The data center of the future. Actually, the future mentioned here is not very far away. In fact, we are already very close to this kind of future data center. Already developing towards higher ideals, we can take a look. First, let's look at it from the perspective of the enterprise's demands and the main functions of the data center. The concept of data centers is no longer the same as the previous civil engineering concept. The content of the data center should at least include the site, environment, the three parts of IT infrastructure and monitoring management. Ensure the reliable and stable operation of the information system through the site environment. The IT system is the IT technical facility on which the information system relies for operation. Monitoring management includes effective management of the site and IT. For instance, here fire alarm temperature. This could probably be said to be monitoring of the site's basic infrastructure. IT technical facilities are, for example, your physical devices. Is the server running properly? Is the network device running overloaded? So this is all about monitoring management. The second one is features of the data circle. So we have discussed this feature before. Modular data center, green data center, and intelligent data center. So here we also have a concept called cloud data center. In fact, the cloud data center in our development history, I have also covered it. This modular data center is designed to meet unpredictable business and the demand for crazy IT growth. At the same time, according to IT requirements, control costs and operational management, modular power supply and modular intelligence provide this kind of uninterrupted business. This is our modular data center. So what is a green data center? Energy consumption of the data center. We know it's very serious. So adopting various technologies and methods to reduce operating costs. In fact, to put it simply, it's about reducing our PUE value. So we will discuss the PUE value in a moment. Also, there is the intelligent data center. The intelligent data center realizes our IT facilities, IT processes and venue facilities, etc. Unified monitoring management can support energy assets, real-time information simulation, various technologies such as remote monitoring. Finally, it is what we are talking about. Now more of what's called a cloud data center. The basic characteristic of this cloud data center is there is a large-scale infrastructure. In other words, there are many servers, network equipment, and storage devices. The second is that there are various virtualization technologies to improve the utilization of resources. The third one is the flexible expansion capability. Pay as you go only when needed. I don't have to pay anymore when I don't need it. In this form, finally, it's automated operations. Actually, the concepts we are discussing here, we will help everyone here to check in first. Then in some of the later courses, we will explain these things in detail. So when everyone is listening to this class, there might be many small doubts. No need to worry about this. After we have finished the HCNA course, all these doubts will be addressed accordingly. So we've actually talked about the PUE value several times, right? Let's see what the PUE value actually means. PUE is the efficiency indicator of data center energy. What is its calculation formula? This is the total power consumption of the data center. Eliminate the energy consumption of IT equipment. What does this mean? It is the total power consumption of the data center. What might it include, for example? Including air conditioning. Then this thing is definitely not ours. The energy of the IT facilities on the denominator is available. Then you can take a look. From this formula, we will know. Is it that the closer this value is to 1, isn't it better? It's me. What I hope for more is this IT equipment in my data center. Its power consumption is the total power consumption of my data center. I don't want any more of this air conditioner. Things like UPS for power supply. Is it to consume my energy consumption? So, the lower our PUE value, the better. So generally speaking, our ideal range is 1.6 to 2.0, even lower. Everyone can go and see now there might already be situations like 1.2, 1.3. It will be there. So the common range might be from 2.0 to 2.5. Even higher, this is all there is. So let's measure the PUE value of this data center. It can then be measured to see what it really is. Is it a green data center now? So this is the PUE value. Everyone can have a simple understanding. So about the infrastructure of this data center, let's briefly understand. Take a look at this thing. We from the system perspective, let's see what's there. We know the basic infrastructure of the data center is integration of multiple subsystems. So this picture shows our current understanding at Huawei L1 layer of the data center. Everyone, please note that it is the infrastructure of layer 1, definition of the multi-system. We can see from this system, it is divided into these 8 major systems. For example, this one power supply system, including diesel generators, ATS, UPS, DC power cabinet, AC power cabinet, static conversion switch battery and battery rack power cord, and so on. This is for power supply. For instance, this refrigeration, including what might be called precision air conditioning, comfortable air conditioning and ventilation systems, etc. Everyone can see many systems in this picture. Take a look for yourself. I won't introduce more on my end. So this is our several basic infrastructures, 8 major systems. Well, of course, this might just be about some products. So these products, we are not saying it can be used in the data center because of its data center construction. It's actually a site engineering project. It needs to meet certain functions or to meet some users' needs. So we must always stand from the system's perspective. Looking from the perspective, and it's not just about simply seeing. Look at this device from the perspective of the product. So we are really going to build when in the data center, we must consider the combination of devices transition. Can it be complementary to each other? Is it possible to be accompanied by some? Corresponding designs? Design and installation of the system. Meet the user's needs. Then let's take a look at the infrastructure again. Last page, which is the classification of our infrastructure system. So from this system classification, so we can take a look, what does it include, including the buildings, structural, electrical, HVAC and drainage, right? So every system, it has some corresponding functions. For example, the electrical system, it needs to meet the power supply requirements of the device. Air conditioning system needs to meet various environmental requirements, air conditioning adjustment requirements. Firefighting system need to meet the requirements of fire alarm and fire extinguishing. Low voltage system complete the communication of the data center, security prevention, environmental equipment monitoring, and so on. So these are all different systems. So now let's introduce what products are included in each system, or what does it include. For instance, the decoration system. What does it mainly include? Including some decorations of heaven, earth, and walls. Decoration and the electrical system, including some power supply systems, UPS, power distribution system, lighting systems, etc. So the cabinet here, relatively speaking, it is quite special. Some people also put the cabinet in the decoration system, or it can be said to be within the low voltage system. Because we know the low voltage system, it is to complete data communication, right? It might also be placed in this also, there is the air conditioning system. The air conditioning system includes the precision air conditioning we just talked about, comfortable air conditioning, fresh air system, and smoke exhaust system. There are only 2 left. There are still the last 3 fire systems. The fire protection system is an alarm for some fires. Weak electrical system, it's just some integrated cabling, communication, monitoring equipment, and so on. The final management system is some large platforms, large monitoring platform, large screen display, and so on. So we just spent some time introduced our data center. classification of infrastructure. That is some basic infrastructure of the L1 layer. Next, let's talk about the L2 layer, which is our IT infrastructure. Rather than the data center infrastructure here, so generally speaking, we refer to the typical data center. Perform logical partitioning. This logical partition, we look at it from a vertical perspective. Vertically, what can we be divided into? From top to bottom is the external access layer. Look at this external access layer. There might be some. For example, connecting to the internal network, connected to the dedicated external line, connected to the internet. It's also possible that I'll connect two of my remote disaster recovery system. These levels, we are called the external disclosure layer, the second level. We are called the network core layer. It is to connect the entire data center network, including the levels just mentioned. Then further down is our server access layer. Then this layer is undoubtedly, it is our large number of servers. Our server will be connected to our network core layer. So the last layer is the storage layer. The storage layer is our storage device. Generally speaking, our storage devices will connect to our server. In the data center, servers usually provide our computing resources, and the storage device provides storage resources. In plain terms, it's disk space. You can understand it this way. So this is vertical stratification. Then we can reverse it. Let's look at it through horizontal partitioning. We can divide horizontal partitioning into, for instance, the business district test area, big data zone, DM, jet zone, management area, and so on. So this might be differentiated based on various business scenarios. So this is our typical logical partition of the data center. So since we've looked at the logic, so let's take a quick look. Typical physical networking architecture. So the network architecture corresponds to it. The vertical stratification just now is also good. External access, layer core, layer server layer. The storage layer is still different partitions. After we put these physical devices in, you will find this is the data center's typical network architecture. Of course, these areas actually in the cloud-based data center, it is actually logical. You can understand it this way. It is logical, although it has many business divisions, but physically, you can consider it as a whole physical whole. So these things everyone will understand in the subsequent courses. So let's take a simple look again. These few concepts, one called DC, a thing called pod, also called AZ. This DC stands for data center. It is the data center. Actually, the three concepts discussed here. Basically speaking, all are physical from a physical perspective. So the first DC, it is a complete data center. It includes things like L1 layer, L2 layer, and so on. So what is this pod? This pod is called point of delivery, called distribution point. So how do we understand? I propose what is the best suitable example. For example, my container modular data center. Do you understand it as it is the pod, right? Because this thing is included in my pod. And that one called AZ. What does AZ mean? Called available partition. Actually, this can be partitioned. It's actually the concept of logic. It mainly represents fault isolation area. Mainly due to some hosts, they all used the same power supply system, and network facilities. In that case, this can be partitioned when these facilities encounter problems, so the resources in this part are no longer available. So we generally refer to this as AZ. Just define it this way. When everyone is understanding this data center, you may encounter this concept. So this is some physical concepts of the data center DC pod. So next, let's learn more about this VDC. So what does this VDC mean? It is called the virtual data center. So what is the concept of this virtual data center? We can take a look at this from the diagram. The first one on the left is this physical resource you can see from this diagram. For example, this firewall switch router with balancing equipment server, storage device, so this. These are some of our physical resources. Of course, these physical resources of ours, shouldn't they all be placed in inside the data center? So take these data centers. through our this virtualization software of cloud computing. At this time, we can then take these things. A virtual resource pool has been formed. So at this time, what you see has become VFW vSwitch. VM stands for virtual machine. So when I allocate the physical resources after being abstracted into virtualized resources, we can then divide these resources divided into different VDCs. So in each VDC, it will cover some VFW, VLB, vSwitch VM and so on. So actually VDC, you can understand it as a real data center. It's just this quota. It is controlled by human intervention, can be large or small. So there is also tenant called tenant. This tenant, it's just my one VDC. It's the tenant. You need to take responsibility and manage this data center, this VDC. Then in the tenant, he has the user of the tenant administrator and the tenant's administrator. It is to maintain the entire VDC. So the tenant's user, it is to use these resources and it is applied to this tenant administrator. So this is some perspective from a logical point of view. The previous page is from this physical. This page is viewed from a logical perspective. The concept of VDC and tenants. Okay, so we've talked about VDC. Actually, there are inseparable things called VPC. It might be a bit convoluted. Everyone might be a bit dizzy. What is VPC called virtual private cloud, called virtual private cloud? Actually, you can take a look at this picture. We talk about inside the VDC. What kind of virtual firewalls will there be? Virtual load balancing device? Is it a virtual router, virtual machine? So there are so many of these devices. How do we use it? Let's talk about what you think of my VDC. He looks at it from the perspective of the public cloud. He should be the tenant. Is he possibly the enterprise? So if we talk about within the private cloud, he might consider VDC as a department. Then look at it from the perspective of our department. If we talk about the finance department of the company, the normal kind of business department, in theory, the information security between them. Once I have completely virtualized this resource, so how is this information security managed? We will go through this VPC. We discuss VPC. It is a security domain, you can understand it as I put this. This finance department is placed in a VPC. Then this business department is placed in another VPC. And such implementation between different VPCs achieves secure isolation. So this VPC, it will also provide some corresponding networks. For instance, a direct connection network, routing network, and internal network. There are many concepts. So these concepts in the following courses, I will introduce each one to everyone. So what else will be provided? Various services will also be provided. We have a firewall in this. So in this solution of ours at Huawei, we can do some NIT through the firewall. IP, this conversion of the IP address as well as things about IP, sec VPN. It will be provided in this VPC, so to speak. This concept of our VPC, it's actually a virtual private network. In plain terms, it is a virtual private network. Inside this private network, you will see it inside the VPC firewall. There is a router. This is all virtual. Also, subnet. This subnet is the network segment subnet. Then each network segment will have some virtual machines to isolate it from the other VPC network, protect the entire network. So this is VPC. So we have said so much. What is this resource after all? How are they combined together? Let's take a look. The concept is called DCN's Fabric. This is also Huawei in when emphasizing the data center. Important term, fabric. So this fabric. What is it? From this diagram, we can take a simple look. This is fabric. You can understand it this way. This fabric is based on this spina leaf. Such a typical layer 2 fat tree, networking, the architecture formed by it, we are called fabric. So in this fabric, generally speaking, this spina, it is our core. In large scale data centers, we generally use this spina exactly CE, which is a 12,800 and leaf. It's just some TOR devices. Exactly, access layer switch, that is this one in the Huawei Data Center CE58687888. These access layer switches formed by this fabric of DCN. This DCN refers to Data Center Network. Data Center Network Fabric. So this is our fat tree networking. So why is it such a fat tree network? What are the benefits of this? Firstly, it's our kind of network setup. It is a flat structure. So this data-driven data, traffic forward, its path will be very short. In that case, the forwarding efficiency will be relatively higher. The second one is easy to expand. If I say my leaf is not enough, then I can draw a few more leaf, can be flexibly expanded and contracted, and it is fully interconnected networking. So its security is very high. So similarly, this fabric of DCN, we have also adopted this virtualization, our key technology. It is VXLAN. So about VXLAN, it supports this overlay. So about this fabric, about this thing called fabric. In this certification at our learning center, it is also a relatively core knowledge point. So everyone can focus on the content of this part, go for a deep understanding.